Okay, friends, let's start once again. Now, let me first of all summarize for you what we have studied so far. The analysis part or the modeling part is almost over. So, what we have done so far is I have introduced you to the concept of state space modeling, and we have tried to compare it with transfer function modeling. Then we took up some circuits and obtained the state space models. And we also discussed the various nomenclature associated with state space modeling of analytical systems, isn't it? और उसके अलावा हमने फिर देखा कि अगर हमें सिस्टम का ट्रांसफर फंक्शन दिया है उसका स्टेट स्पेस मॉडल हम कैसे रियलाइज कर सकते हैं उसके हमने तीन कैनोनिकल फॉर्म स्टडी किए फर्स्ट कंपेनियन फॉर्म सेकंड कंपेनियन फॉर्म and Jordan's canonical, isn't it? That's what we have done so far, and in between we have done some assignments also.
Yes, sir.
Last time, what did we do?
We just studied eigenvectors and
We
eigenvectors.
discussed eigenvalues and eigenvectors.
And
Then we
we
discussed
proved
that similarity transformation, how we can transform any state space model into Jordan's canonical forms by similarity transformation.
Yes, sir.
और हमने ये भी देखा कि अगर एक सिस्टम है, अगर एक मैट्रिक्स A है, उसको अगर हमें डायगोनलाइज करना है,
Yes, sir.
तो उसके लिए हमें सेट ऑफ आइगन ऑब्टेन करने हैं उसके.
Yes, sir.
हमने वो वाला केस लिया था जिसमें रियल और डिस्टिंक्ट आइगन
Yes,
वैल्यूज,
sir.
और हमने देखा कि उसमें अगर हम आइगन वेक्टर्स स्टैक करेंगे ए के और उसको एज अ सिमिलरिटी ट्रांसफॉर्मेशन मैट्रिक्स यूज करेंगे, देन वी कैन ट्रांसफॉर्म आवर मैट्रिक्स इनटू डायगोनल.
Yes, sir.
Is that clear?
Yes, sir.
That is what we have studied so far. So all these things shall be kept at the back of your mind once I move
Yes.
further. What we'll discuss today is solution of state equations. Now that we have the model of this form, x dot equal to ax plus bu, y equal to cx plus du, where x at t naught, that means initial state, is defined like this. Okay, I want a solution of this equation. Solution of this, it's a matrix differential equation. Matrix differential equation, this one. And this is an algebraic, a set of algebraic equations. Okay?
Yes, sir.
मॉडल तो हमने ऑब्टेन किया, लेकिन किसी भी सिस्टम का एनालाइज करने में जो स्टेप्स हैं उसमें पहला स्टेप तो हमने कर लिया कि सिस्टम को हमने मैथमेटिकली मॉडल किया.
Yes, sir.
कोई भी सिस्टम जो आपको दिया हुआ हो जिसको आप एनालाइज करना है, डायनेमिकल सिस्टम आपको दिया हुआ है, तो इसकी एनालिसिस में जो स्टेप्स हैं, द फर्स्ट स्टेप इज दैट यू ऑब्टेन इट्स फिजिकल मॉडल. ओके,
Yes, sir.
पहले आप इसका फिजिकल मॉडल ऑब्टेन करते हो. मींस जो आपको डायनेमिकल सिस्टम दिया हुआ है
Yes, sir.
उसकी फिजिक्स स्टडी करके आप उसका फिजिकल मॉडल बनाते हो.
Yes, sir.
Then you convert this physical model into its mathematical model. You write down the mathematical equations governing a physical system and then obtain the mathematical model of a system, isn't it?
Yes, sir.
So once you have the mathematical model with you, then you solve it. Solution of mathematical model. फिर आप इसको सॉल्व करते हो.
Yes, sir.
वरना ये सेट ऑफ डिफरेंशियल इक्वेशंस आपने सॉल्व करनी है. जैसे मान लो अगर ये एक सिंपल इनपुट आउटपुट प्रॉब्लम है कि आपको इनपुट दिया हुआ है, आपसे आउटपुट चाहिए हमें, तो आपको क्या करना है, ये इनपुट दिया हुआ है, मुझे आउटपुट चाहिए, तो इसमें अननोन x है.
Yes, sir.
तो ये x में मुझे इस इक्वेशन से ऑब्टेन होगा क्योंकि x की डायनामिक्स को गवर्न करती है ये डिफरेंशियल इक्वेशन.
Yes, sir.
इनपुट तो पता है मुझे,
Yes, sir.
तो मुझे ये इक्वेशन सॉल्व करनी पड़ेगी. Once I solve it, I'll get x,
Yes, sir.
and that I will substitute here and I'll get the output.
Output. Yes, sir.
So you have to solve the mathematical equations. Okay, and once you solve it, you have to again give a physical interpretation. Okay,
So
you have to physically interpret it. These are the various steps in system analysis. Okay, जैसे मान लो सर्किट है, कोई भी सर्किट है, उसको हमें सॉल्व करना है, तो आपको एक डायनामिकल सिस्टम दिया हुआ है, पहले आप उसका फिजिकल मॉडल बनाते हो।
yes, sir.
जैसे सर्किट इक्वेशंस, जैसे आप जो भी फिजिकल प्रोसेसेस उस सर्किट में होते हैं, उसको आप तीन मेन सर्किट एलिमेंट से रिप्रेजेंट करते हो, रेजिस्टेंस, इंडक्टेंस, कैपेसिटेंस से, तो बन गया फिजिकल मॉडल।
Yes, sir.
फिजिकल मॉडल को फिर बाद में मैथमेटिकल मॉडल में कन्वर्ट करते हो, लिखते हो इक्वेशंस इसकी। मैथमेटिकल मॉडल किस फॉर्म में है, दैट्स टू बी सीन, वेदर यू हैव पुट द मैथमेटिकल मॉडल इन ट्रांसफर फंक्शन फॉर्म, स्टेट स्पेस मॉडलिंग फॉर्म, अब सिंपली डिफरेंशियल इक्वेशन फॉर्म में ही है, तो आपके पास मैथमेटिकल मॉडल है।
Yes,
तो नेक्स्ट स्टेप आपके पास बन जाता है आपको उस मैथमेटिकल मॉडल को सॉल्व करना है,
Yes.
isn't it? So अब हम सीखेंगे ये वाला स्टेप,
Solution of
क्योंकि मैथमेटिकल मॉडल तो हमने ऑब्टेन किया
Yes, sir.
स्टेट स्पेस मॉडलिंग फॉर्मेट में,
Yes.
अब हमें देखना है कि इसको सॉल्व कैसे किया जाए।
Yes, sir.
So that's what this topic is, solution of state
equation. Yes.
समझ आया?
Yes.
So in order to make you understand the solution of state equations,
Yes.
I'll take you back to the concept of solution of differential equations, normal scalar differential equations. मान लो आपके पास एक इक्वेशन है, let's say you have an equation x dot is equal to ax. Okay,
Yes, sir.
where x of t naught is defined as x naught. It's the single differential equation. It's a scalar differential equation. That means a single differential equation. Are you getting me?
Yes, sir.
This a is a scalar. A is a scalar.
Yes.
Now this is, ये equation ऐसी है, मान लो dx पे dt equal to ax, है ना?
Yes, sir.
इसमें u वाली टर्म नहीं है, so it's a homogeneous scalar differential equation because there is no input term. Okay, so do you remember how you used to solve this equation in mathematics?
Yes, sir.
We have to see what the solution with non-zero initial conditions x naught.
Yes.
हमें देखना है कि इसका solution क्या होगा। तो कैसे करते थे इसको solve आप? We used to do like this. Let us assume that xt is equal to k e to the power at is the solution of this equation,
Yes, sir.
where k is a constant. हम एक कैंडिडेट सॉल्यूशन अज्यूम करते हैं,
Yes, sir.
तो हम देखेंगे क्या ये इसका सॉल्यूशन हो सकता है, कैन दिस बी अ सॉल्यूशन ऑफ दिस इक्वेशन, देन वी कैन अज्यूम इट. So for it to be a solution of this equation, the solution must satisfy this.
Yes, sir.
What I do is I differentiate this equation just to see whether my candidate solution is okay or not.
Yes, sir.
So I obtain something like x dot
K
is equal to k
A
a
E power 8
e to the power at, which I can write as a k e to the power at.
80
K e to the power at is x,
AX.
which is ax. So x dot equal to ax. So this candidate solution is satisfying the given equation,
Yes, sir.
which is the given equation. है ना?
Yes, sir.
Since xt is equal to k e to the power 80 satisfies equation 1, therefore this can be a candidate solution for this equation. So yeah,
Yes, sir.
this can be a candidate solution for this equation.
Yes, sir.
Now the point is, इसमें k भी unknown है.
Yes, sir.
k का वैल्यू हम कैसे ऑब्टेन करेंगे? k का वैल्यू हम ऑब्टेन करेंगे फ्रॉम द इनिशियल कंडीशंस.
जी सर.
The value of k will be obtained from initial condition. Value of k will be obtained from initial conditions. कैसे करेंगे वो obtain? हम इसमें इस इक्वेशन में इनिशियल कंडीशन सब्स्टिट्यूट करेंगे. तो मान लो ये इक्वेशन 2 है. So in equation 2, if I put t naught for t,
Yes, sir.
I'll get x of t naught is equal to k e to the power a t naught.
Yes, sir.
मुझे इनिशियल कंडीशंस पता है ना?
जी.
That's x naught, isn't it?
Yes, sir.
Or I can write x naught is equal to k e to the power a t naught. k चाहिए ना मुझे?
Yes, sir.
Which implies k is what?
X naught by
e to the power minus a t naught
X
x
naught.
naught. So yeah,
Yes, sir.
this I will substitute in equation 2. So this I will substitute in equation 2. We have what? xt is equal to, what is k?
X naught e power a t naught.
K is e to the power minus a t naught x naught, है ना?
X naught. Yes, sir.
Then you have e to the power a t, है ना? है ना यहाँ पे?
Yes, sir.
So that is xt is equal to e to the power a t minus t naught x naught. Isn't it?
Yes, sir.
This is the solution of this given differential equation. This is a homogeneous scalar differential equation, a single differential equation.
Yes, sir.
Xt equal to e to the power a t minus t naught x naught.
Yes, sir.
But the equation that I have to solve is a matrix differential equation, where this a, even if I take a homogeneous differential state equation, that will be x dot equal to capital A into x,
Yes, sir.
while A is a matrix, n cross n matrix.
Yes, sir.
So I want to have a similar solution for that equation. Keep this solution at the back of your mind. xt equal to a to the power a t minus t naught x naught. मान लो अगर मुझे इनिशियल कंडीशंस पता है, x0 मुझे पता है और मुझे xt चाहिए.
जी सर.
मान लो t naught 0 है, 0 सेकेंड्स पे मुझे x का वैल्यू पता है, मुझे 3 सेकेंड्स पे x का वैल्यू
जी
चाहिए.
सर.
I'll put t is equal to 3. So x t is 3 is equal to e to the power a 3 minus 0 into x naught. E to the power a भी पता है, given scalar value. So I will substitute it here. E to the power that thing will be calculated and I will be able to get x.
Yes, sir.
Isn't it? I want a similar solution for my state equation. That is x dot equal to ax. मेरी actually जो equation है वो ये है, x dot
Equals to x.
ax ऐसे,
सर अब इसको डिफरेंशिएट
जिसमें कि x of t naught defined है x naught.
यस सर.
इस इक्वेशन और इस इक्वेशन में फर्क है. फर्क क्या है? फर्क ये है कि ये तो एक इक्वेशन थी, लेकिन ये सेट ऑफ इक्वेशन है.
यस सर.
क्योंकि x जो है ये वेक्टर है, इसका साइज n क्रॉस 1 है, इस a का साइज n क्रॉस n है और ये भी n क्रॉस 1 है. So it's not a single equation,
जी सर.
it's a set of
सेट ऑफ
equations.
इक्वेशंस. यस सर.
And A is a matrix. Here A was a scalar.
यस सर.
Here A is a matrix. So it's a matrix differential equation. Matrix differential equation. Are you getting me?
यस सर.
So I want a solution of this equation on the same pattern.
यस सर.
On the
सेम.
same pattern. In order to obtain the solution of this equation on the same pattern, I will have to learn some more mathematics. Are you getting me?
यस सर.
So we'll keep this at the back of our mind, and We will remember that we have to solve this equation, and I will introduce you to some mathematics that will be needed in getting the solution of this equation on the same lines on which we have solved the scalar differential equation.
Yes, sir.
Are you getting me?
Yes, sir.
Okay. So keep this at the back of your mind. Consider an infinite series in X defined as fx is equal to alpha naught plus alpha 1 x plus alpha 2 x square plus so on, alpha k x to the power k plus so on. Infinite series. Okay?
Yes, sir.
With a radius of convergence r. What does that mean? That means if the value of x is less than this r,
Yes, sir.
we are assuming that this function, this infinite series converges. Because I can write like this: summation of I is equal to 1, I is equal to 0 to infinity, alpha I
X.
xi.
Yes, sir.
I am considering an infinite series in X defined as this with a radius of convergence r. Radius of convergence r means that if the value of x, or if the absolute value of x is less than r,
Yes, sir.
then I am assuming that this function converges. Are you getting me?
Yes, sir.
Converge means that you are able to get some value for this, a finite value for this. Okay?
Yes, sir.
Then there is a theorem which states that the corresponding matrix function, matrix function means if I replace x by some matrix A, square matrix,
Yes, sir.
so I'll get alpha naught I plus alpha 1 A plus alpha 2 A square plus so on, alpha k A to the power k plus so on is equal to summation of I is equal to 0 to infinity alpha I A to the power I. Then there is a theorem which states that the corresponding matrix function also converges if the absolute values of the eigenvalues of A are less than R. There is it states that the corresponding matrix function, this FA,
Yes,
FA is obtained where you replace x by A.
Yes, sir.
A is a square matrix.
Yes, sir.
That's why this I has come here. अभी तक अल्फा स्केलर था ना,
Yes, sir.
यहाँ पे क्योंकि जब मैट्रिसेस को आप ऐड करोगे
Yes, sir.
तो वो compatible होने चाहिए ना पर addition.
Yes, sir.
So that's why this I has come here.
Yes, sir.
Okay, and A has to be necessarily a square matrix because you are computing A square
Yes, sir.
and A to the power cube and so on, and that can be computed only for square matrix.
Square matrix.
अगर इस मैट्रिक्स A के आइगन वैल्यूज R से कम है तब ये मैट्रिक्स फंक्शन भी कन्वर्ज करेगी.
Yes, sir.
तो अगर आपको एक इनफाइनाइट सीरीज दी हुई है x में, where x is scalar है,
Yes, sir.
and if this has a radius of convergence r, that means for the value of absolute value of x is less than r, then this function is converging. Then the corresponding matrix function fa also converges if the eigenvalues of a are less than r.
Yes,
Are you
sir.
getting me?
Yes, sir.
ओके, ये जनरल एक इनफाइनाइट सीरीज के लिए एक्सप्रेशन है। नाउ कंसिडर f of x equal to 1 plus x square upon 2 factorial plus so on x to the k upon k factorial plus so on। ये भी इनफाइनाइट सीरीज है, ओके
Yes, sir.
लेकिन मैंने एक स्पेसिफिक इनफाइनाइट सीरीज ली, 1 plus x square upon 2 factorial plus so on xk upon k factorial plus so on।
Yes, sir.
So this is actually summation of I is equal to 0 to k, sorry 0 to infinity x of 0 upon x of I
X of I.
upon I factorial,
Yes, sir.
है ना?
Yes, sir.
What does this function converge to? Do you have some idea?
Sir, this is a binomial expression, right?
किस चीज का expansion है ये?
It's-
This function converges to e to the power x for all finite x। e to the power x का ही expansion है ना?
Yes, sir.
e to the power x is equal to 1 plus x square upon 2 factorial plus so on xk upon k factorial।
Yes, sir.
किसी भी finite x के लिए this converges, that means इसका जो radius of convergence है, that's all finite x।
Yes, sir.
किसी भी finite x के लिए ये function converge करती है to e to the power x।
Yes, sir.
Are you getting me?
Yes, sir.
Then by the same logic जो मैंने अभी आपको बताया, so there will be a corresponding matrix function, f of a is equal to I plus a square upon 2 factorial plus so on a to the power k upon k factorial plus so on, which is summation of I is equal to 0 to infinity 1 upon I factorial a to the power I,
Yes, sir.
which will also converge to e to the power a for all a having finite eigenvalues। Are you getting me?
Yes, sir.
जो मैंने पहले आपको स्टेटमेंट बताई कि अगर आपके पास एक इनफाइनाइट सीरीज है जो कि कन्वर्ज करती है within some radius of convergence r,
Yes, sir.
then the corresponding matrix function also converges if the eigenvalues of a are smaller than r।
Yes, sir.
By the same logic, if I consider a particular function infinite series in x,
Yes, sir.
which is this, and we know by mathematics that it converges to e to the power x for all finite x, then there will be a corresponding matrix function fa wherein I am replacing x by a, which will also converge if the eigenvalues of a are also finite,
G, sir.
isn't it? And it will converge to something known as e to the power a। So that means e to the power a is actually this, जैसे e to the power x हम लिखते हैं ना ऐसे।
Yes, sir.
So e to the power a is written something like this। So what is e to the power a then equal to? E to the power a is I plus a square upon 2 factorial plus so on a k upon k factorial plus so on, an infinite series।
Yes, sir.
e to the power a is equal to this is known as matrix exponential. क्या बोलते हैं इसको?
मैट्रिक्स
मैट्रिक्स एक्सपोनेंशियल. जैसे हमने जो प्रीवियस इक्वेशन जब सॉल्व की ना हमने,
यस सर,
जो मैंने x डॉट इक्वल टू ax ली थी,
यस सर,
उसके सोल्यूशन में ये वाली टर्म आई e टू द पावर a x माइनस x नॉट आया था ना.
यस सर,
उसी पैटर्न पे हम कुछ ऐसा डिफाइन करने की कोशिश कर रहे हैं जिसमें कि इसका पावर एक मैट्रिक्स है. मेरी बात समझ रहे हो आप?
यस सर,
e टू द पावर, जैसे आपको e टू द पावर 2 इवैल्यूएट करना है, ये तो आप कंप्यूटर कैलकुलेटर पे इवैल्यूएट कर सकते हो. लेकिन अगर ये इसका पावर मैट्रिक्स है,
यस सर,
उसको कैसे इवैल्यूएट करें, वो हम दिखाने की कोशिश कर रहे हैं.
जी सर,
सो दिस इज नोन एज द मैट्रिक्स एक्सपोनेंशियल.
जी,
और ऐसी टर्म्स आप एनकाउंटर करते हो जब आप सॉल्यूशन ऑफ स्टेट इक्वेशंस, जब आप व्हेन यू सॉल्व द प्रॉब्लम ऑफ सॉल्यूशन ऑफ स्टेट इक्वेशन. आर यू गेटिंग मी? Explicitly what type of terms you get there is e to the power at. What will be e to the power at equal to? It will be I plus at plus a square t square upon 2 factorial, है ना?
यस सर,
Plus so on a k t to the power k upon k factorial plus so on, है ना?
यस सर,
Which is actually equal, it can be written like this: summation of I is equal to 0 to k, है ना? सही है? a to the power I t to the power I upon I factorial.
I factorial, yes sir,
This type of expression you will find in when you solve the state equation.
yes sir,
Are you getting me?
yes sir,
First of all, we'll state the properties of this matrix exponential. What are the properties of this matrix? अभी हमने देखा नहीं कि हमारे इक्वेशंस के सॉल्यूशन में कैसे एंटर करेगा, लेकिन हमने देखा है कि जो हम अगर हमारे पास स्केलर डिफरेंशियल इक्वेशन है, उसका सॉल्यूशन कुछ ऐसा होता है.
yes sir,
Isn't it? If you have a scalar differential equation, the solution is something like, was it x minus x naught or t minus t naught in the solution?
t minus t naught,
t minus t naught था ना?
yes sir, t minus t naught into x,
ऐसे था ना?
yes sir,
Into x naught था ना ऐसे?
yes sir,
ऐसे था solution equation. Do you get me?
yes sir,
So I want a solution in the similar pattern for a matrix differential equation. And we will see that when you solve a matrix differential equation, we'll encounter this type of term in that, which we have called as the matrix exponential. Are you getting me?
yes sir,
We'll study the properties of this matrix exponential. Do you get me? कहीं पे भी कोई डाउट हो, you have to stop me.
yes sir,
We'll talk about the properties of. वीडियो कितना बड़ा हो गया?
27 minutes,
Properties of matrix exponential. Matrix exponential क्या होता है? It is e to the power at. सही है?
yes sir,
पहली प्रॉपर्टी इसकी e to the power a 0 is equal to I. Okay?
yes sir,
What is the proof for this? We know that e to the power at, what is that equal to? I plus
I
at
plus at,
plus a square t square upon 2 factorial plus so on.
yes sir,
A to the power k t to the power k upon k factorial, है ना?
yes sir,
Plus so on. सही है? Now put t equal to 0. So what is e to the power a into 0? That is equal to, in sum में t है ना?
yes sir, submit yes will be 0,
So it will be simply I. सही है?
yes sir,
And it's proved. सही है?
yes sir,
स्केलर ये जो इक्वेशंस होती हैं इस टाइप की, जैसे e to the power 0 किसके बराबर होता है? 1 के बराबर होता है.
yes sir,
तो हम जो स्केलर एक्सपोनेंशियल टर्म्स में की जो ये प्रॉपर्टीज हैं, वो हम देखेंगे, वो सारी हम एक्सटेंड करेंगे टू मैट्रिक्स एक्सपोनेंशियल.
yes sir,
ये हमने पहली प्रॉपर्टी देखी. सेकंड प्रॉपर्टी, second property is e to the power a t plus tau okay, is equal to e to the power at e to the power a tau. ठीक है,
Yes, sir.
इसका प्रूफ e to the power a t plus tau किसके बराबर होगा? I plus a into t plus tau, है ना,
Yes, sir.
plus a square t plus tau square upon 2 factorial
Yes, sir.
plus 1 a k t plus tau raised to k upon k factorial plus 1. ठीक है ना?
Yes, sir.
So e to the power a t plus tau is equal to I plus at plus a tau. सही है?
Yes, sir.
Plus a square. What is this? This is t square plus tau square plus t tau.
Yes, sir.
है ना?
Yes, sir.
Plus upon 2 factorial plus 1. है ना?
Yes, sir.
That is e to the power at plus tau is equal to I plus at.
A tau.
है ना? at plus, then we will write a square t square upon 2 factorial.
Yes, sir.
Plus 1 plus a tau, है ना,
Yes, sir.
plus a square tau square upon 2 factorial. सही है?
So, sir.
प्लस ये भी है ना, 2a square t tau upon 2 factorial. 2 उसमें कैंसिल भी हो सकता है, so I get a square t tau.
Yes, sir.
plus 1. आएगा ना ऐसे?
Yes, sir.
तो ये मैंने कुछ टर्म्स इसकी एक्सपैंड की.
जी सर.
Now I will take this one. I'll try to prove that once I expand both the sides, I'll get similar terms.
Yes, sir. Then we will.
तो मैं कुछ टर्म्स तक हम देख सकते हैं कि बराबर होंगी. मेरी बात समझ रहे हो आप?
Yes, sir.
ये e to the power a t a tau जो है ना, ये किस चीज के बराबर होगा? It will be I plus a t, है ना?
Yes, sir.
Plus a square t square upon 2 factorial plus 1.
Yes, sir.
Into what is a I e to the power a tau? This is I plus a tau plus a square tau square upon 2 factorial plus 1. है ना?
Yes, sir.
सही है?
जी सर.
तो इसको जब आप मल्टीप्लाई करोगे, I into I means I, है ना?
Yes, sir.
80 into I means 80. That is this.
Yes, sir.
है ना ये वाली टर्म भी?
जी सर. 80.
A square t square upon 2 factorial into I means this term.
Yes, sir.
A tau into I means this term.
A tau into tau. Yes, sir.
है ना?
Yes, sir.
A t into a tau means a square t tau.
E square in t tau. Yes, sir. Sir,
A square t tau square upon 2 factorial into I means this term.
E square t square.
A square tau square upon 2 factorial into
yes,
I.
sir.
That means this term.
Yes, sir.
तो इसी तरीके से अगर और भी टर्म्स आप देखोगे, इसमें सभी टर्म्स सेम आएंगे.
Same idea.
So you can see if you expand it, you will get these terms, all these terms.
Yes, sir.
So you'll get you'll get I at also, you'll get a square t square upon 2 factorial also, plus so on, है ना?
Yes, sir.
Plus you get a tau, you'll get a square tau square upon 2 factorial. ये सारी terms आपको मिलेंगी.
Yes, sir.
Plus a square t tau and so on. है ना?
Yes, sir.
इसमें आप कुछ और terms के लिए भी अगर आप इसको expand करोगे, इसका थोड़ा आगे ले जाओगे,
Yes, sir.
so you'll get all these terms there. Are you getting me?
Yes, sir.
So which implies LHS is equal to RHS, hence proved. Are you getting me?
Yes, sir.
आपको याद है जब हम ऐसे कुछ करते हैं स्केलर फंक्शंस में, if you have e to the power x plus y, we can write it as e to the power x, e to the power y.
Yes, sir.
So same thing we are trying to extend to matrix exponential. Do you get me?
Yes, sir.
तो मैट्रिक्स एक्सपोनेंशियल के लिए भी ये वाली थ्योरम ट्रू हो जाती है. सही है ना?
Yes, sir.
So this becomes your equation number 2. Now third property.
Yes, sir.
Even this will be equal to, ये इस चीज के भी बराबर होगा. If you write it like this. This will again be the same.
Yes, sir. Same आ जाएगी.
Are you getting me?
Yes, sir.
Now property number 3. Property number 3 is e to the power at का inverse. That's e to the power minus at. आपकी मास्क का है? मास्क लगा. आजकल बड़ा खराब सिचुएशन है इसका कोविड का. e to the power at inverse is e to the power minus at. Okay?
Yes, sir.
इसका proof. If you write like this, e to the power at and e to the power minus at.
Minus 80.
By the property number 2, you can combine the powers.
Yes, sir.
I'll be able to write it as e to the power at minus at,
18. Yes, sir.
which will be actually equal to e to the power 0.
Yes, sir.
And we have already seen that e to the power 0 is I by property number 1,
Yes, sir.
which is equal to I.
I.
That is, which implies e to the power at into e to the power minus at is I. And you know from the property of inverse of matrices, we know that A into A inverse is always equal to I.
I. Yes, sir.
So means ये वाला matrix इसका inverse है,
Yes, sir.
है ना?
Sir, I get it. Yes, sir.
Which implies e to the power minus at is e to the power at का inverse.
Inverse. Yes, sir.
तो ये प्रॉपर्टी भी स्केलर फंक्शंस की हमने इसमें प्रूव की. जैसे मान लो आप यू हैव गॉट समथिंग लाइक दिस e to the power ax raised to minus 1. It's always equal to e to the power minus ax.
Yes, sir.
So e to the power at inverse is equal to e to the power minus 8. That means e to the power 8 is an invertible matrix. This implies that e to the power 8 is an invertible matrix because it satisfies the property of inverse of product of inverse of two matrices.
Yes, sir.
Are you getting me?
Yes, sir.
So this is property number 3. Now property number 4. Property number 4. d by dt of e to the power at. d by dt of e to the power at is equal to a e to the power at, which is also equal to e to the power at into a.
Yes, sir.
जैसे मान लो आपको a अगर स्केलर है e to the power at का आपको डिफरेंशिएशन करना है, इसकी डिफरेंशिएशन क्या होगी? a e to the power at. Same thing we want to prove for the matrix exponential also.
Yes, sir.
Are you getting me? तो इसका प्रूफ हम देखेंगे. What is e to the power at? That is I plus at plus a square t square upon 2 factorial plus 1. है ना?
Yes, sir.
What is d by dt of e to the power at? इसका डिफरेंशिएशन करेंगे.
Yes, sir.
Firstly get at the differentiation. I'll get a. इसकी डिफरेंशिएशन तो 0 ही.
Yes, sir.
सेकंड वाली टर्म का a आएगा.
A
थर्ड वाली टर्म का क्या आएगा?
2a square.
a square नहीं.
A square बाहर आएगा.
2a t square upon 2 factorial.
Yes, sir.
है ना?
जी sir.
इसमें 2 और 2 कैंसिल हो जाएगा. है ना?
Yes, sir.
अगर मैं यहाँ पे एक और टर्म भी लिखूं, I have a cube t
सर
cube
पर
upon.
हम तो t कर रहे हैं ना सर. A तो बाहर आएगा ना. A
Sorry.
square.
What will be here? It will be
2a
actually,
square t.
sorry, हाँ, 2a square t upon 2 factorial, है ना?
जी sir.
This 2 and 2 will go. Now this is a cube t cube upon 3 factorial here, है ना?
Yes, sir.
So when I get here, I'll get a cube. I'll get 3t square
3t square
a cube
divided by 3 factorial
divided by 3 factorial plus 1.
plus 1. Yes.
3 factorial means 3 into 2.
Yes, sir.
3 goes. है ना?
Yes, sir.
So I'll get d by dt of e to the power at. I'll get as a.
A को बाहर ही निकालेंगे.
हाँ, a को हम कॉमन निकालेंगे.
सर वहाँ बचेगा I.
वहाँ पे रहेगा I
plus 80
80
divided by
plus
80 plus
a square t square upon 2 factorial plus 1,
इस रे वापस आएगी.
which is actually a e to the power 80.
Yes sir.
सही है?
Yes sir.
Here this a could have been taken out even on this side.
A power 80. Yes sir.
I could have written this expression equivalently as I plus 80 plus a square t square upon 2 factorial plus so on, और ये a मैं यहां से बाहर निकाल सकता था. सही है ना?
Yes sir.
क्योंकि ये a का ही प्रोडक्ट है ना?
Yes sir.
So I could have taken this a on this side also, which would have come out to be e to the power 80 into a.
Yes sir.
So d by dt of e to the power 80 is a e to the power 80 or e to the power 80 into a.
Yes sir.
Are you getting me? This is property number 4 of the matrix exponential. Are you getting me?
Yes sir.
तो ये चार प्रॉपर्टीज हमने मैट्रिक्स एक्सपोनेंशियल की डिफाइन की. इन चार प्रॉपर्टीज को यूज करके हम अब होमोजीनियस मैट्रिक्स डिफरेंशियल इक्वेशन का सॉल्यूशन देखेंगे कैसा.
Yes sir.
I'll get you now back to the problem which we are actually solving. Do you get me?
Yes sir.
Now coming back to the problem of solution of equation of this type, x dot equal to ax. अभी हम u इसमें assume नहीं कर रहे हैं, u वाली term, where x of t naught is defined as x naught. I have to solve this equation.
Yes sir.
I follow the same pattern in which we have solved the scalar differential equation. I assume a solution of the form xt is equal to, okay,
Yes sir.
k e to the power 80. I assume a solution of this form,
Yes sir.
where k is a constant vector. वहां पे वो स्केलर था, यहाँ पे वो वेक्टर होगा. Are you getting me?
Yes sir.
Now on the same pattern, I'll first of all check whether this can be a solution.
Yes sir.
So if I differentiate it on both sides, that is x dot t will be k, isn't it?
Yes sir.
K, it should actually be satisfying this equation.
Yes sir.
है ना? इसका जो solution होगा e to the power 80 का, जो हमने देखा अभी,
E power 80 A.
e to the power 80a या a e to the power 80,
Yes sir.
isn't it? I can even assume a solution of this type, like this. Okay?
Yes sir.
So I can write it as a e to the power 80k.
Yes sir.
क्योंकि इसका डिफरेंशिएशन यही होगा ना?
Yes.
अभी हमने प्रूव किया ये. Where this a e to the power 80, what is e to the power 80k? That is x,
X.
which is actually ax, which is the given equation.
Given. Yes sir.
Which is the given equation, which implies xt equal to e to the power 80k can be a candidate solution. Okay?
Yes sir.
It can be a candidate solution for this equation. Now what needs to be found in this equation is k. So previous case में हमने k कैसे obtain किया? From the initial condition.
Initial condition.
So the value of k will be obtained from the
Initial condition.
initial condition. Will be obtained from the initial condition. सही है? ठीक है?
Yes sir.
So what is x of t naught? That will be e to the power a t naught into k. है ना?
Yes sir.
और k is equal to, ये यहाँ से इसका इनवर्स हो जाएगा. हमें पता है कि ये इन्वर्टेबल मैट्रिक्स है, हमने वो प्रूव किया
Yes sir.
कि मैट्रिक्स एक्सपोनेंशियल इन्वर्टेबल मैट्रिक्स होता
Yes
है.
sir.
So I can pre-multiply it by e to the power a t naught inverse.
Yes sir.
So this will be e to the power a t naught inverse, है ना?
Yes sir.
Into x t naught. सही है?
Yes, sir.
और अभी हमने प्रॉपर्टी नंबर 3 जो देखी मैट्रिक्स एक्सपोनेंशियल की,
E power 80.
e to the power 80 inverse is e to the power minus 80.
Minus 80.
So this is actually e to the power minus 80 naught into x of t naught. सही है?
Yes, sir.
So substituting it in this equation, in the solution equation, so substituting in ये 1 रखेंगे हम, ये 2 रखेंगे. So substitute in equation 2, we have what? xt is equal to e to the power 80. What is k equal to?
E power
E to the power minus 80
naught.
naught x of t naught, which is actually equal to xt is equal to, by property number 3, property number 2, I can combine the powers.
Yes, sir.
So this is e to the power a t minus t naught into x t naught.
Yes, sir.
Are you getting me?
Yes, sir.
So you can see that the solution is exactly similar to the solution that we have obtained for a scalar differential equation.
Yes, sir.
With the difference that in that case x was a scalar that was to be obtained and a was correspondingly also a scalar. In this case a is a matrix.
Yes, sir.
Are you getting me?
Yes, sir.
If the initial time t naught, if the initial time t naught is taken as 0, is taken as LTI systems के लिए हम हमेशा initial time t naught 0 ले सकते हैं क्योंकि उसमें टाइम मैटर नहीं करता, वो टाइम इनवैरिंग सिस्टम्स होते हैं. तो उस केस में व्हाट विल बी xt इक्वल टू e to the power 80 x naught. Are you getting me?
Yes, sir.
Like this. x of 0 आप ऐसे लिख सकते हो. So this is the solution
Yes, sir.
of a homogeneous matrix differential equation.
Yes, sir.
अब इसमें अब ये प्रॉब्लम कंप्लीटली सॉल्व नहीं हुई. e to the power अगर इसका पावर स्केलर हो, जैसे e to the power 2 या e to the power 1, वो आप इवैल्यूएट कर सकते हो.
Yes, sir.
लेकिन ये मैट्रिक्स एक्सपोनेंशियल है. अगर ये मैट्रिक्स है ऊपर, how do you solve it?
Yes, sir.
So that remains our next topic. How
Yes,
do we solve this matrix exponential?
Yes, sir.
इसको सॉल्व कैसे किया जाता है,
Yes, sir.
वो हमारा नेक्स्ट प्रॉब्लम बनता है. लेकिन इतना पहले आपको समझना है कि अगर आपके पास एक स्केलर डिफरेंशियल इक्वेशन है, दिस इज द सॉल्यूशन. सॉरी, मैट्रिक्स डिफरेंशियल इक्वेशन होमोजेनियस, जिसमें कि इनपुट टर्म नहीं है अभी, तो ये उसका सॉल्यूशन होता है.
Yes, sir.
आर यू गेटिंग मी?
Yes, sir.
इसके बाद हम इसमें एक्सटेंड करेंगे. It will extend it to a non-homogeneous differential equation. Will include the term x dot equal to ax plus bu,
Yes, sir.
and then solve that equation and see what will the solution like, and then we will see how do we solve for the matrix.
Yes, sir.
Are you getting?
Yes.
Let's stop here.